Hello, students. Today we're working on the second day of the chain rule. And so I'm going to show you some examples that might just have some unusual circumstances that you may not recognize what to do with the chain rule. So the first one is kind of a comparison of when you have a trig function with an angle that requires the chain rule, as opposed to the second one, which is a trig function that actually has a power and requires the chain rule. So we'll look at number one, and it says y equals the sine of 3x. So you have to recognize that the angle is more than just an x, so that when you do the derivative y prime, that will equal, first of all, you do the derivative of sine, which would be the cosine of 3x, and then you multiply by the derivative of the angle. And the derivative of 3x is 3. So we're going to multiply by the derivative of 3x, which is 3, and then write your final answer as y prime equals 3 times the cosine of 3x. And you may want to put that angle itself in a parentheses, maybe even to begin with. All right. Your second example is a parentheses to the third power. And you may want to actually write it that way because it's not showing the parentheses, but it actually is. So you may want to do a rewrite of f of x as the sine of pi x. And I'm actually going to go ahead and put the pi x in parentheses as the angle, just so there's no confusion there. But what I'm really talking about is that the entire function is to the third power. Sine to the third of pi x means that it's the sine of pi x all to the third power. So this is actually going to require the chain rule a couple of times. So the first time, I'm going to draw a little separator here. The first time we have always the outside function gets done first. So f prime of x is going to equal 3 times, and now you're going to keep the inside function, so sine of pi x, and reduce your exponent by 1. So 3 times the sine of pi x squared. Then you have to do the derivative of the inside. So the derivative of sine would be the cosine of pi x. And then you have to do the derivative of the angle, because the angle is not just an x. So we'll multiply by the derivative of pi x, which is pi. So you see that we actually used the chain rule a couple of times while we were completing this derivative. So f prime of x, not a whole lot of simplifying can be done, but I would recommend putting the 3 pi as a coefficient, and then you have the sine of pi x squared. And I think there you could probably go ahead and leave off the parentheses around the angle, and then the cosine of pi x. You just want to have clarity what is the angle and what is not. So 3 pi times the sine of pi x, quantity squared, times the cosine of pi x would be that final answer. So those are your first two trig functions. I'll clear this and we'll move on to numbers 3 and 4. So on number 3, I would again recommend a rewrite as I did in problem 2. So rewriting h of t as 2, and then the the cotangent of the angle pi t plus 2, and then all of that raised to the second power. So h prime of t would equal, we want to bring the 2 from the exponent and multiply it to the 2 coefficient. So that would be 4. We want to keep the inside. So that would be the cotangent of pi t plus 2. Then we want to do the derivative of the inside. So the derivative of cotangent is, now it's a so it's negative cosecant squared of the angle, pi t plus 2. And then finally, we're going to multiply by the derivative of the angle. And the derivative of pi t plus 2 is pi. So you can see that this is quite a long chain. So again, we started with the outside. We multiplied that and we reduced our exponent to 1, keeping the inside. So not changing the inside. Then we did the derivative of the inside of the parentheses, and we kept the angle. And then finally, we did the derivative of the angle. So just a tiny amount of simplifying. And by simplifying, mostly I just mean rewriting it. So h prime of t would equal, we could make it 4 pi, actually negative 4 pi. And then just have your 2 trig functions. So the cotangent of pi t plus 2 times the cosecant squared of pi t plus 2. So you'll find that often with trig functions, you'll have multiple times that you have to do the chain rule. All right, I'm going to have to clear the screen for number 3 in order to make room for me to write for problem 4. And so for problem 4, I'm hoping that you'll recognize that you have a product rule. So we will not do a rewrite, but I am going to just call this to your attention that this would be first for the secant of 1/2 theta, and then tangent 1/2 theta would be second. So g prime of theta, and you'll want to write small so that you can fit all this in. G prime of theta would be first, so secant of 1/2 theta times the derivative of the second. Well, the derivative of tangent is secant squared of the angle 1/2 theta. But since your angle is not just theta, it's not just this singular variable, we have to do the derivative of the angle. So we'll multiply that by 1/2. All right, and then we're going to do plus second. So second would be tangent 1/2 theta. And then we'll have to do times the derivative of the first. So we're doing the derivative of secant 1/2 theta. Well, the derivative of secant is secant tangent. So we'll do secant of 1/2 theta times tangent 1/2 theta and then we have to do the derivative of the angle, which is 1/2. So we'll have to multiply by 1/2. And that is then your derivative line. So there are a few things that you can do to clean this up. We can make g prime of theta equal and just kind of look and see what factors we can put together. So we can bring the 1/2, this 1/2, we can bring it in front and then have our secant squared and just secant be combined to secant to the third of 1/2 theta. So that would clean up the first part of our derivative. And then our second part, after the plus sign, we have this tangent of theta. We have two of those, so we could put that together. We also have another 1/2 that we could bring out into the front. So we have 1/2 again, and then we could have secant of 1/2 theta times, and then since we have the two tangents, we could say tangent squared of 1/2 theta. And that would be okay to have for your final answer. Let me clean up my brackets here a little bit. So you could have it like that. That would be fine to have for a final answer. Or it's possible that if you would have to work on setting that equal to 0 at some point, you might want to have it in factored form. So in factored form, you could take out a 1/2 secant of 1/2 theta. And if you factor out that, then you would be left with secant squared of 1/2 theta plus tangent squared of 1/2 theta. And down the road, there might be things that you could do with that, but we'll leave it like that. So that's a factored version of that final answer. Either of these last two lines would be acceptable. So you can leave it in either one of those forms. So I'm going to do a second video for the last part of the notes, but these are your first 4 examples for doing some trig functions using the chain rule.